Hello everyone and welcome back to another math video. Today we're going to be talking about the quadratic formula, so similar to the problems that you see up on the screen here. Just a reminder, this is the speedrun version where we go through it pretty quickly. If you want the normal version, I'll link that in the description below. For your Ricasso Recap, you should already know how to simplify radicals, you should know how to factor quadratics. If you want refreshers on these two topics, I'll link videos in the description below. Please go watch those before you start this lesson. All right, new lesson starts now. Here we go. So we have a quadratic equation that they want us to solve. And we've been following this list, right? Step 1, it's in standard form. Step 2, there's no greatest common factor. It has 3 terms. It's not a perfect square trinomial. And in the last lesson, we learned, okay, we do A times C add to B. However, this problem, that does not work. There is no combination, no magic numbers. So we need a new tool to solve this. And the new tool is called the quadratic formula. This is the quadratic formula down here. We can sort of just ignore the x equals for now. And it looks a little scary, it looks a little ugly. Promise it won't be that bad. I'm going to sing for one and only time on this channel that you will hear me sing. I'm going to sing the quadratic formula. I find that some students, it helps them remember it. I'm going to sing it to the tune of Pop Goes the Weasel. Here we go. Negative b plus or minus, and then you take the square root of b squared minus 4ac all over 2a. I hope that helps somebody. Now, you'll notice the quadratic formula has lots of A's, B's, and C's. And so we have been finding A, B, and C a bunch. Should feel comfortable with that. A equals 1, B equals negative 7, C equals negative 12. And now what we're going to do is we're going to substitute. We're going to replace, right? I see B equals negative 7. I'm going to put that here. I'm going to put it here. Okay, anywhere I see a B, that's, and so on and so forth. My suggestion would be anytime you replace a letter with a number here to put it in parentheses. It's just easier to keep track of your symbols. So you'll notice the quadratic formula starts with a minus sign. So I'm going to start with a minus sign. Then I'm going to put in B. So I'm going to put parentheses. B is negative 7, so I put in negative 7. This plus minus here, that's how you read it, plus minus. We're going to talk about that at the end of the problem. For now, just leave it in your problem and work with it. Then we do the square root of b squared, so that's negative 7 squared, minus 4 times a, which is 1, times c, which is negative 12, all over 2 times 1. So we've replaced all of our letters, a, b, and c, with numbers now. So now we can simplify a little bit. I see this minus minus, that just means positive 7, plus or minus, square root of negative 7 squared is 49. And then for this, I'm doing negative 4 times 1 times negative 12, which will give me plus or positive 48, all divided by 2. We can now do 49 plus 48, which will give us 97. So we have 7 plus minus the square root of 97 divided by 2. This radical, square root of 97, cannot be simplified, cannot be broken down in any way. So this is actually our final answer. This plus minus symbol just means there are 2 answers. The first answer says 7 plus square root of 97 divided by 2. The second answer says the same thing but with a minus symbol. It's 2 answers written as one answer. This plus minus symbol just makes it easier for us to write our answers. For this problem, let's assume we did all the steps, and once again, we have to do the quadratic formula. So we're going to plug in our a, b, and c like normal, like we just learned how to do. So after we've plugged in everything, we get to here, okay? But what's new here is that the square root of 12 can be simplified. All right, we should know how to do that already. The square root of 12 gets simplified into the square root of 4 times the square root of 3, which becomes 2 square root of 3. So now we have negative 10 plus or minus 2 square root of 3, all divided by negative 4. So at the end of your problem, you need to check, can I simplify the radical first off? But now you need to check, can I simplify even further? Because this is a fraction, and fractions can be reduced. And so I see this negative 10 over negative 4, negative 10 over negative 4, and then I see this 2 over negative 4. All right, I'm going to make two suggestions here, two things we need to really pay attention to. One, I would ignore the negative signs for now. There are ways to simplify the negatives and make things positive, but I find some students lose it in the process, get confused by it. So for now, let's just ignore the negative signs. Secondly, when you reduce these two fractions, you must reduce by the same number. Can't pick two different numbers, okay? In this case, the number that I can reduce both of them by is 2. If I reduce 10 over 4 by 2, I get 5 over 2. And if I reduce 2/4, I get 1/2. So now, our final answer looks like this. 5 over 2 plus or minus 1 square root of 3. Remember, there were negative signs on the 10 and the 4, so let's make sure we keep those in our final answer. Notice here is the 5 over 2, okay? And here is the 1/2. Lastly, most answers will not put this 1 in front of the radical, so most answers are going to look like this as the final answer. You can put the 1, perfectly fine. Both answers are technically correct, but most answers will not show it. All right, here's our cool clock for today, which means that it's time for you to practice what you just learned. Go ahead and pause the video and try these two problems on your own, and when you're ready, you can unpause the video and we'll check your answers. Okay, now that you've had time to work these problems, let's check your solutions. Okay, for the first problem, here is the work and final answer. And for the second problem, you might notice something strange here. You're getting a negative under the radical. There are ways to solve negatives under radicals. They're called imaginary numbers, but for this lesson, we're not going to worry about that. If we get a negative under the radical, we're just going to stop right there, and our answer is NRS, which just stands for no real solutions. No real solutions. My S is getting cut off. All right, that is it for today. I hope you all have a good morning, good afternoon, good evening, and good night.